Okay, so this is integral science. Um, okay, so what is integral science? Well, we were talking about that last video, just a synopsis in case you're just coming in right now. Integral science is a way to take all the different theories and philosophies, put them together, and for the first time in history really be able to look at them all and then see if and how they're connected. Um, you might argue that we've been able to do this for some time and there's been nothing really fruitful from this, but I would argue that there have been a few things in the way for a while, and necessarily so. But in Western tradition, especially scholarly tradition, there have been philosophical movements that which basically reject any kind of greater meaning and emphasize the meaningless and the relative. For good reason, because our old ideologies were very, even though they were trying to be conclusive and inclusive, were very Western centric or anthropocentric, or they were basically gross overgeneralizations without understanding the details and differences. But now that we've gone over the details and differences, we finally have an opportunity to see how it works from the bottom up. We're not trying to create some kind of grand scale theory yet, but we're trying to see some kind of general tendencies and patterns that arise out of this seemingly chaotic cultural mesh that we all have, that we're all part of. And the results are very interesting. There are some, um, arguably, there are some aspects which everybody shares, and not just biologically, but also cognitively, how we develop and how societies develop, actually have very similar stages. And I know there's a big argument that societies don't develop. There is no evolution of the human society, of civilization. Everything's pretty much stagnant. We still fight. We still kill each other. We still have religions. We still have all this stuff, and nothing has really fundamentally changed. Um, and from my point of view, and this is just sort of how I kind of answer that through integral perspective, or whatever you would like to call it, um, when something is evolving and changing and becoming more complex over time, it doesn't necessarily change radically. It has a period that you might want to call this chaotic build-up period, where we're faced with some kind of problem that doesn't go away, and there's something about us that fails at solving that problem. So we spend most of this time slowly adapting to this new issue to the point where it eventually reaches a breaking point where either we will cataclysmically collapse and become extinct or adapt. And if you want to read more about this, it's a view of evolution which sees it as exponential and not linear. So, past philosophical traditions have seen evolution as this nice and neat linear development. It goes in a straight line and it goes up. But it's not so simplistic, of course. In modern traditions, we've said, oh, it's not like that at all. You haven't taken account anything relativistic. So let's go down to the nitty-gritty details and see each individual point of view, each culture and each attitude and each philosophy. Let's take it at face value and just and each his own. And this is to a degree right, but by discovering this chaotic worldview, chaotic and decentralized, we kind of assume that, well, there doesn't seem to be any real greater connection. It's not God. It's not industrial progression. It's not this. Well, I guess there's no real underlying theme going on here. Everybody's different. The only thing that is underlying, I guess, is just biology and physiology, and that's not really changing. We're kind of just stuck the way we are. Let's do our best to make the most of it. But imagine if this happened to evolutionary theory. Imagine if all of a sudden we realized that, no, well, this is what we did realize. A few 200 years ago, 150, sorry, roughly, we kind of realized, oh, well, you know what? Things change, species evolve. But instead of seeing some kind of, and this is true, evolution is exponential and it's developmental because species that existed now are much more complex. Not all species, but a lot are much more complex than they used to be. Our brains are a great example. The reptilian brainstem, which evolved into the mammalian, frontal lobe and all that, and our brains are more complex than other species, other mammals. So we have a direction. It's not that evolution doesn't have a direction, but it's also not that evolution isn't completely decentralized, so that the chaos doesn't eventually make sense and go towards something. This is true of evolution, and arguably this is true of our cultural and technological evolution as well. So imagine 100 years ago, we're trying to figure out evolution, and the more we find out about it, the more complex it seems. And then all of a sudden, a couple scientists start to say, well, obviously, since it's so complex, there can't be any kind of greater meaning. There are too many variables. We can't simplify it and reduce everything to this general linear perspective. Oh well. Well, you know what? They couldn't do that. But they rose to the challenge by studying all of these chaotic different interactions and dynamic ecosystems, some extinct, some presently alive, trying to understand how species transform and change, and trying to understand how it's somehow all connected, what the general tendencies of this chaotic living organic earth is, because it wasn't a framework. The framework is something we imposed on it. So we tried to kind of understand what was actually going on, and we had enough data to begin to see general tendencies that evolution shared overall. And two tendencies are, one, that evolution becomes more complex over time, and the second is that it's non-linear, but it's chaotic. It's exponential. So you have seemingly all these random things happening all at once and over time, but they seem to lead to a greater emergence, a greater complex form in the end. And it's usually an explosion. It's a gradual build-up. So if you imagine, we have 1 grain of rice, and this is a Kurzweil example. We have 1 grain of rice, and then, hold on 1 second. You have 1 grain of rice, and then you have, every minute you double over that grain of rice with 2 grains of rice. After a while, you're going to have a hell of a lot of rice, but for the first 10, 20, 30 times, every second you sequentially add another grain and you double it over, you're only going to have 2 grains of rice, 4 grains of rice, 8 grains of rice, 12 grains of rice, but eventually you're going to have a full pot of rice, and then eventually that pot's going to double over and become 2 pots. Then you're going to have a tub, and you're going to have more and more rice as it doubles over time. So as the sequential moments go by, you're going to have a lot more rice in the end, and you're going to be getting a lot more rice per moment than you would before. Let's say it's 1 second. So let's say after 50 of these turns, the first turn you only had 2 grains. In the end, I don't know, I'm not doing the math right now. Let's say you have 100. 100, and then another 100, and then another 100, and it just keeps doubling over. So eventually you have this explosion of rice. This is sort of what happens with evolution. You have certain adaptations and certain new forms that kind of pop up, and they kind of double over, and they don't really seem to be doing anything yet, but then all of a sudden there's an explosion, and then this explosion, very chaotic, very not really organized, has a general tendency. It's more complex, and it's happening faster. More complex and happening faster. So, as an integral scientist or integral theorist would take a look at our culture and our society and sort of try to see if this is true too, because this would be a wonderful way to sort of map out some underlying theme that we all share, and that's what a lot of people are trying to do, and I'll explain a few different forms of that in the next video.